Hey, welcome to the 13th episode of Distributed.NET Core. It's Peter
Direct.
and today we'll focus on the test. However, we'll not be talking about the unit test. We'll focus on the more interesting and I also think the more trickier part, which is the
Yeah.
integration testing. And you will see that it's kind of difficult and sometimes even impossible to do this sort of integration or even end-to-end testing when it comes to microservices and distributed systems in general. And this is going to be like the first part, because I think that also in the next episode we'll talk about testing, because this is quite a broad topic.
Yeah,
But
actually,
today
I would say that was the one that was quite frequently requested by all of you guys. Because of course some of you spotted that we had no unit test at all,
yeah
and that's simply because we don't do any mistakes, and that's about it. And we don't need to test it. But with no kidding, we simply had another things. We added some integration tests, and to make it clear, we did not introduce the test a whole bunch of tests to whole system. We just created some samples how your integration test might look in your projects. So just to make it clear, we did not test the whole application.
yeah, exactly. And you'll see like how much code you need to write to handle some special use cases, especially when it comes to your infrastructure, databases, message buses, and so on. So, all right. So let's get into the code. But I think that you have one tab opened in your Chrome.
Yeah, I think we should start with the very with this GIF, which actually illustrates greatly how what are the unit tests and what is the integration test. So I think that it's worth mentioning because, as Piotr said, we'll not introduce any unit tests, mostly because this is sort of I would say that the basic level of testing. So this is on the lowest level of the hierarchy, right? So unit test basically is about creating isolated environment for your particular component. So you want to mock or stop everything that your component depends on and see whether this actually works. While the integration test is the one level above, which actually tries to test whether your components put together actually make sense. So in this case, even though that the each open actually works itself, so imagine that the two unit tests actually pass. In general, as the whole system, as a system put together from the two components, it does not work because they're not integrate with each other. So this is the whole idea. If you have never written any integration test, so that's what you should imagine this look like. So we'll go to the code, right? And I think that we should go through to this and see what's actually this consists of.
So at first, let's just say what we're going to use. So we'll use the basic xUnit test framework, which is default for the core.
Yeah, we can go here and see our dependencies. Yeah.
And we'll also use these packages called MVC testing and ASP.NET Core test house. I'm not sure if test house is actually required. I think the MVC testing is the newer one.
I think that it used to be. I think that this is now should be fine with this.
Yeah. So previously there was this test house, but Direct just removed it. But recently they also added this MVC testing package, which basically I think it still uses the code from the test host package. It just gives us better abstraction. So for this episode, we'll stick to the basic libraries provided by the ASP.NET Core team, and this is actually quite a cool stuff, because we can actually create our integration test that will run in memory. I mean, in this scenario, we won't be able to, mock the database or mock the message bus, which is not really the point of integration testing. We'll still have to run these infrastructural parts and services in some way using Docker or some other tools. But you can imagine that you would create, your web app or your web API without any external dependencies, maybe only using anti-framework core that you can still use with your in-memory provider, and you could use this package, to run the run the integration testing fully in memory, which could be even part of your build pipeline. So it's pretty cool. Okay, and I also think one thing worth to mention is that as you can see, we have this app settings JSON file copied here.
Yeah.
So so here's the thing. If you copy it, we copied this file from our discounts, like our base SRC discounts project. And if you copy this file, you also have to enable it. You also have to mark it as content, right? And
if you go to properties, you'll see that.
Because the thing is that once you start running iteration testing, and your debugger or your runtime will try to actually load those app settings, and by default, for example, let's say you're using the ASP.NET Core library for integration testing, and by default it will look within your bin debug repository for this app settings JSON file. So if it's not part of your integration test project, well, it will not be there, so we'll not be able to run this. You can override it. You can actually override this startup that you use for testing, and for example, point it either to use some environment, which could be like test, and you could have this, let's say, app settings test JSON in your base discounts repository in that case, or you could change the so-called content route to actually be the path of your discounts. So starting from bin debug would be like four layers above. You have to go 4 layers above in your path to set it, so that set a content route to your actual project. So there's multiple ways you can do it, but we stick to the simplest one, which is just copying app settings JSON. That's what they are here.
Yeah, but just once you do this, just remember, make sure that you actually set this to here to copy always, because that's crucial for this technique.
And also, and also keep in mind that if you're actually building your ASP.NET Core app, which uses, for example, Razor and CSS, HTML, JavaScript, and other types of assets and files that are, for example, rendered on the server side, you actually have to use content route, because you won't be able to test your views, right? Because otherwise you'll have to copy your views to the integration test directory, which really doesn't make sense. So, but this is for web API testing. Okay. So let's
so I think that we should go through this because as you see that we have this additional project, which is the part of this of our GitHub repository right now. So this contains, as you see, the integration tests. As you see, we have 3 folders here. So first one is the compose, and this contains the Docker compose files, and we'll get to this part a little bit later. So we'll just leave it as it is. Then we have two additional catalogs. The first is the config and the fixtures. So as you probably imagine, we would like to test our, in this case, the discount service, want to create an integration test. So we would like to see whether a bunch of the components that our discount service consists of actually make sense when we put them together. So we want to make sure that actually the command handlers and the aggregate routes and the repositories and everything that actually is involved in the whole process of processing data, so either writing or reading, actually when we put this together, it makes sense. So this actually, it either stores some data into MongoDB or returns some data from internal API. So to make our life easier and actually to make it running one way or another, we need to create these fixtures for MongoDB and for RabbitMQ, because let's imagine that we would like to test whether our discounts are actually available at some endpoint. So before we actually run the test, we would like to seed the database with some data, with some example data. So for this, we need some connection to MongoDB, and that's what this whole fixtures are about. So basically, this MongoDB fixture and RabbitMQ fixture wrap the clients for the particular libraries and allows us to interact with this. So that's what this is all about. And I don't think that with this whole that there is an explanation needed for this right now. The only thing that you should really care about is that because this is a fixture, we would like to make sure that actually we will create some test environment before we run whole tests, and after all we will delete this. So for this purpose we implement the iDisposable interface, and we actually implement whole disposable pattern. So if you'll see in the constructor we actually create the whole for this for the MongoDB, we create the whole client and we connect to the database and so forth. And in the dispose you'll see that we actually drop this database. So once we actually run the whole test, we'll create a MongoDB database for the testing, and once we actually finish whole test, it will be gone, will be not available. So we will not, of course, use the same database as we'll use in the production, because that makes no sense, because we could screw something up, and this is more safer and I would say the only preferred way of doing this. And the same thing with the RabbitMQ.
Yeah. Also, some people could argue that you could always provide some additional level layer of abstraction. And for example, let's say you are using Anti-Framework Core, and with EF Core, as I already mentioned, you have this option to, for example, switch from SQL Server to in-memory provider, right? And then you can run your integration test quite easily, because you don't really have to have your database up and running, and you can always switch to provider. But there are some limitations, like for example, your EF Core provider will not support transactions, and you have to do some sort of ifs or switches for that case. So the question is, you could either abstract these things away, and maybe instead of RabbitMQ use in-memory dispatcher, and the same for the MongoDB. But then really, is that a point of integration testing? I mean, still you could test some components and how they behave, and do they work or not, but you will not get this value that you're looking for, because you will not know how to actually work with the actual RabbitMQ or MongoDB or other infrastructural service up and running. So
I would say that at this point that would look more like a unit test, because you would try to mock your provider, because you're having this additional abstraction layer. You would try to I would say the exchanges for some in-memory provider or something else.
Yeah.
Then there's probably or I would say it this way, something could happen in your code, and you would not be certainly sure that this actually is the same thing that you hit on the production. And creating this temporary databases and the connections to the real not marked components gives you this thing that actually, once you actually test this, you could be centrally sure that this will also work on the production, because you're not using some fake providers just because you have these layers.
Yeah, so you really want to have your infrastructure up and running. You don't want to create stubs, because this will not give you real value.
Yeah. Oh, I screwed this up. This should be is. Yeah. Oh, it can be. Okay, sorry. Because this is the
good. Okay. So let's create the first test.
So that's the purpose of this fixtures. The same thing here, and this also implements the disposable pattern. So you'll see that at the disposing we actually dispose the bus client. So we want to make sure that will not leave some trash here. So we should start with actually implementing the tests using these fixtures.
Let's start with the basic ones. So the simplest ones, which would be like, let's say we have the set of endpoints in our API, and we would like to check whether our endpoints actually exist, and they just return 2 OK, and they just don't return values or not found for all four. So let's start with this controllers test. And in that scenario, we'll need to use the fixture for this ASP.NET Core integration testing stuff. So let's
so we have this
fixture
iClass fixture, and this is provided by the xUnit itself.
Yeah.
Right.
So let's start with this web application factory.
Right.
So you can Google it. Basically, this part of this ASP.NET Core testing library, and here you can use this generic factory of type T, where T is your startup class.
So we need to here to type
provide
the startup of the discounts, right?
Discounts, yeah. You do have a reference to your discounts. I mean, also keep in mind that you can easily override this. So you could basically override your whole startup configuration either by creating your own let's say custom web application factory of T and override the startup config, or you could play your test startup, which derives from startup. There are multiple ways you can do it, and you can Google it. It's an official ASP.NET Core testing docs.
Yeah, it's worth to mention that once you actually try to create your custom application factory, this also needs to be generic for some bizarre reason, because we tried to create a custom factory which was not generic, and we simply hard coded this startup, and that did not work. So shame on you, Microsoft, that we don't know why this
Yeah, it's not the only issue, but I mean, it's okay.
It's not the only issue. That's a great great ad for the Microsoft.
All right, cool.
Right,
so let's create a constructor now.
Yeah? And by doing this, why do we actually need this fixture?
Well, because we want to start our web API in memory, so we can access the HTTP client and send requests to our API.
Yeah.
So we don't have to start it as a separate application and then use VS Code, Postman, or some other REST client to test requests, or even for the xUnit HTTP client. We want to start our web API in memory and just execute requests in memory and make it work as it was an app.
Yeah, so that's very cool way of doing this. All right, so we actually go to the test itself. So I'll create, because we already know that we'll have some communication with the API. We can expect that this will be done fully asynchronous. So I will create a simple task for this. Now call this, I would say that there's a lot of different conventions, and you can pick your own, but I found that simply once you actually use _ because that's the difference between the names of the tests, methods in the test and in the production code, that actually, the name of the particular method in the test needs to actually express what it does. So it tends to be kind of long, and when you actually use the Pascal case, it could be hard to actually read this. So using underscore is very helpful in this case.
I'm also for underscore when the names are long. Usually I'm using lowercase underscore, but whatever makes sense.
Yeah,
and I also
whatever.
I also prefer this sort of BBD style, which is given when then, because I just look at the class name and I look at the method name and I know what to expect. I don't like this test when it's like I have some whatever test and there is like test sum, or what the hell?
Yeah.
Sum
so
for
this is
what? For
what
under what conditions, right? So.
Yeah. So this is but there are a lot of different. I would say that there are a lot of different conventions here.
Yeah.
And
just be consistent with one.
Just pick what's the best for you. All right. So we have this longish test name which says that the given endpoints should return success HTTP status code. So we would like to see whether actually we will get anything. So we'll not get internal server error or some 4.1 which says that we are not authorized. So we'll just want to see whether actually our API is up and running. So this is the purpose of this test, right?
Mm-hmm.
So we'll expect some success status code. We
need the HTTP client to work with that. So
So I'll introduce the constructor here. And because we have this class fixture, we can inject this in the constructor, right?
Yep, that's the feature of xUnit. That's how it works.
So we have this factory, and we could introduce also some private read-only field which says this is.
I mean, we don't even need the whole client. We can just use. I mean, we don't even need the factory. We could just create a client, a constructor,
Yeah,
which
okay.
will always instantiate for the test. Because the way that xUnit works, if you haven't used it before, for example, with any unit, you use these setup attributes or tear down and so on. With xUnit, you put this initialization logic into the constructor, and it will get invoked for each test. So
Yeah.
it's like your setup
Yeah.
method.
So we have this HTTP client, and the factory gives us the implementation actually, or the instance of this client. And this is one more thing that this is actually worth to mention, that once you actually run your test using this web application factory, this does, as Piotr mentioned, this is run in a memory. So you will not be able to actually reach your web API using the local host itself. But so the only way actually to communicate with this is using this client, using the given factory. So the client itself will be able to communicate using the proper endpoints with this marked with this test application. Yeah.
And you don't have to set any URLs because the base URL will be already set.
Yeah, this is already defined inside. Yeah.
Okay, so let's write this test. It will actually be a very simple test, but that's okay.
All right. So we would like to.
We can do it like a two-liner, I think.
2 lines. Okay, that's great. But I think that we should which are endpoints we would like to test, because if we'll go to the controllers, we see that we have this the default one which returns
these two endpoints, and from the discounts controller, we also want to test these. I think one endpoint maybe, because we can skip the pause one, because we have this pause one here only for the training purposes, because we are not using it, right? Because we are consuming message from the bus, so we could remove it.
Episode 4, I think.
Yeah, we want to test the get one, returning the collection. I mean, the collection might be null. It doesn't care. It should return at least a null collection, or sorry, the empty collection. But we probably won't be able to return the get discount by ID, because we would have to create some specific ID, discount with a particular ID for that case. I mean, we could do it.
Yeah, but these free endpoints are actually fine. And of course, as you probably expect, the xUnit itself provides us some tools for creating one test for testing actually free endpoints, because that would make no sense to create three separate integration tests for testing free endpoints. So we could use this attribute provided by the xUnit called theory, and inside. So the theory itself, it's like that we would like to create the multiple scenarios, and they will be all listed within the one tests as a separate results, I think. So I think that as a result we should get that we have 3 positives or 3 negatives or something, right?
Yeah, so just we can pass here any argument. So we'll just pass 3 strings using this inline data.
Yeah.
I don't know why it shows an error. This is weird.
This is there's no matching method parameter for value and the empty string. That's kind of weird.
I'm sure there is. Okay.
I don't know why.
Let's type here the ping. We'll see.
Yeah.
It seems as if you are using some inline data. Yeah, that's weird. I don't know where it's coming from.
All right, so we'll see in a minute. Okay, so we have this inline data. So actually, this will run 3 times using this 3 parameters, and of course we can pass the value of this to the method.
Yeah,
so we can create
maybe it looks for the value. Oh, it's smart one. It looked for the value and it tried to assign this to the attribute. That's nice.
So this will be actually each of the value in each iteration will be assigned to this endpoint value, so variable. So okay, so we have now the endpoint that we would like to test, and each one will be available in the iteration. So we would like to create a get request. So we'll simply use the client for this purpose. So we'll create the response and we'll simply call the client, and we have this method called getAsync, right?
I need to await it, of course.
Yeah. We need to await this.
And we can just check whether the response succeeded or not, and we have this property here.
Yeah, so the response,
which is this one.
And we have this, if you should see this, that we had this shouldly library, and this actually provides us some assertion, and in a very cool way. So we could say that the success status code should be,
or you can just this should be true. There is also
should be true,
this one.
And we'll know that this should be actually true. Yeah.
You might be also familiar. There is a very similar library. I think it was even before shouldly. It's called fluent assertions, which is pretty much the same.
So, but as we said, you can pick whatever you actually want. So
okay, so I think that's the whole definition of a test. Let's just run it and see if it works.
Yeah, that will be something. Okay, I need to do it like this. So run unit test, no debug. We'll see.
And we should have 3 results.
We should
One
have.
of them should succeed.
But will not have. And we'll see why in seconds. Yep, we have the failed, and if we'll see, you'll get the result that we actually had some issues with connecting to RabbitMQ. And the reason for this is because even though we actually run this in a memory, we still, as you probably remember, the discount service itself needs to connect both with the MongoDB and the RabbitMQ. So if you'll go see, you'll see that we have this add Mongo and we have this add RabbitMQ itself. We need to connect to this. This is not mocked by the ASP.NET Core framework itself, right? We need to actually provide this connection. So we need to actually run this infrastructure. So we'll simply do docker compose, and we'll use the Mongo Rabbit Redis YAML file, and we'll run this in a detached mode. So this should
we could also start the compose that we have in our test directory, right?
What?
We could also start the compose files that we have prepared for our tests, right? But
they don't expose the ports, so that would.
All right, forgot about it.
Because for testing we want to avoid this. So for now we'll just use this one that you can actually find in the DShop repository. For now, we'll then down this. So we'll try once again, and hopefully this time this will
should work
more or less. Just waiting to see. And why I think that I think
you need to rerun all.
I don't know why So for this time, this should, we have 3
cool
results. So it works basically. So the app was able to connect to RabbitMQ and the Mongo. We run 3 separated tests with the 3 different parameters, and 3 endpoints actually returned the success status code. That was cool.
So it means that basically these endpoints are reachable. So once our app is deployed, anyone can actually send an HTTP request, and it will return some successful status code to the API caller. So that's actually some value. All right.
So
let's
of course we can
create another one.
Dig deeper, right? We could explore this API deeper and see. I don't know whether we have the response is the same as we expect or something.
I mean, just before going to this one, what you could even do, you could basically scan the assembly, look for the controllers, or grab the routing table from your application, and just scan the routing table, and based on the routing defined in your web API, just go through all of the routes and run this test automatically. So whenever you actually create or add an endpoint, you could automatically run this test. But feel free to do whatever you want.
Yeah.
You could automate everything.
That's a good point, because you just keep in mind that once you actually change, you will have some breaking changes in your API itself. This will at some point might simply fail. So yeah, and in some scenarios it is good to actually make this automated one way or another.
Yeah, but in some scenarios it's
simply,
good to be explicit.
Yeah.
So
we'll just stick to the basic stuff, and let you
let's
discover this more on yourself.
Yeah. Yeah, let's make another one. So right now we'll try to actually dig into the details of the object that we get from the API endpoint, right?
Yeah.
And we have like two possibilities. Either we could get all of the discounts, or get a single discount, or actually discount details object. So yeah, let's stick to this. Let's try to test whether we are able to ask our API to return to us the discount details object, and see whether the values of these objects are what do we expect them to be.
Yep.
All right. So let's already mark it with the fact attribute.
Yeah. Okay. Yeah. I will just mark this. So in this case, we'll use not the theory but the fact, right? So this will just run once. Yeah. That's the basic attribute used by the xUnit.
Yeah. So maybe let's start with
a little bit more trickier. In this case, with what?
Yeah, maybe let's start with writing the actual HTTP response, and we'll see what's the issue, that it's not enough.
Yeah.
So let's try to just do the response. I mean, get data, deserialize it into the JSON, and we'll see that it's not enough.
We need some discounts, and we need some ID.
Some ID. Yeah.
And what's the ID? Let's make it GUID new GUID, and but this is So we have the response. We need to
this content.
Yeah.
Content string.
This will be of type of string, because we'll deserialize this.
Yeah, and actually, I think also one thing worth mentioning, which is not really like about testing, but more about some possible performance hits. Whenever you are deserializing, reading HTTP response, and you are reading objects that can be quite big, instead of actually writing this, assigning this to string variable, which of course means allocating, your memory.
Yeah.
And if the object is big, it can be moved to the large object heap. So in order to avoid it, what you could do instead is basically create a stream reader, and just, for example, use the I think it was called JSON text reader, and just read stream async, which will read parts of the HTTP request and just deserialize the stream, which is much more efficient.
Yeah,
but this is off topic.
And with the C#8 will be even more cooler, because you will have the asynchronous stream.
Yeah, asynchronous stream, and also all this single instruction multiple data, which means CPU instructions. I never really seen the guy doing JSON deserializer with some crazy efficiency. So a lot of nice stuff getting into the language.
Yeah. So basically, if you have objects like more than, I think that this is 85 kilobytes.
It's exactly 85,000 bytes.
Yeah. So basically, that will be put on the large object heap, and then
which is not the best. Which is not the best place that your objects can be. So
yeah, then you should first of all, think whether this actually makes sense, because this is freaky. This is a lot for the one object, but some sort is. It is So so at this point, so what it does, we have this response, and if you'll see, we have this HTTP response message, and we get the content, read this as string, so it's build set, and we just do the dummy thing. So in this case, we simply deserialize, try to convert the JSON to the discount details DTO itself, we'll not do any try catch and see whether this actually is valid, because it might not be, but we believe it is, just for
Yeah.
this sake.
I mean,
yeah.
we could do it like this, or we could do just if is
Yeah.
not success status code, or we could do the first assertion that response is success status code should be true. And if the first one fails, there'll be like the other ones will
this will be already
not be even checked.
failed test. But in this case, we'll simply do this, leave it as this. So we have the discounts details at this point.
Yeah, but
so we have, I would say that we have the issue, and that was actually spotted right here, that we need to discount a particular, I want to query particular discount, and we have no ID.
Yeah.
And how we
I mean,
actually get this.
you can do these things both ways, and both of these ways are actually they actually make sense or are valid. So we'll present you how we can do it in a way where we will create the resource on our own, and for example, we create a new resource every time we execute a test. But on the other hand, you can also find that some people prefer to, for example, already have some test database. And if you know that there are already some objects in the database, you could just query the DB and return the objects. So there are different approaches that you can use.
Yeah, the seeding. If you want to seed if you have some, you prefer this way, this is totally cool, because you'll just once you actually create the instance of the particular fixture, you'll also do this whole seeding step, and this makes sense. But simply in our case, this is just like 2 tests here, and we simply want to show you the way that this actually works, rather than doing the best practices that you could actually apply to your project. So just keep in mind that you could, if you'll have multiple tests, it makes more sense to actually seed your database before you run this, especially when this in parallel. It makes more sense to seed your database before you run all tests. Yeah.
Okay, so let's add this stuff into database.
So finally we'll use this MongoDB fixture, right? So we'll actually need some connection
to inject it
to this. So we'll add this. So I'll create this class fixture of type MongoDB fixture, and of course we need to inject this to our constructor. So I'll call this MongoDB fixture as it here, and we'll introduce the read-only field. Thanks. Right. Okay. So we have this MongoDB fixture. So what should we actually do is we need to create the discount inside the database, and if we'll go to the details of this DTO, we'll see that we'll also need a customer, because as you probably remember, the discount details DTO contain both information about the customer that the discount belongs to and the discount itself.
Yeah,
so
we'll be invoking the get discount query, which of course this is get discount query handler, which grabs the discount details, grabs the discount object from the database and maps it into discount details. So we have discount and customer details within this object. So this is why we need these 2 objects in our DB.
Yep. And discount is new. Discount will. So first is the ID, then we have the customer ID, which is the customer.id. Then we have the code, which is whatever, in this case could be discount, and we
some
have
percentage.
We have the percentage. So we have 2 entities here. Now we need to actually insert them before we query the data. So we'll use the fixture for this, and if you see, we'll have simply insert async. And we have 2 parameters here. First is the collection name. So we need to specify that first we would like to insert to the customers collection, and we want to insert the customer object, and the same thing applies to the discounts. So we'll use the different collection. In discounts is the discounts, and we'll pass the discount object. So this is Just one more thing. So if you are familiar already with the testing, you know that we distinguish the three phases. So we have this arrange, act, assert. So this part is strictly this is the arrange part. We want to arrange the whole environment and make it prepared for the whole testing. So we would like to insert the data inside to the MongoDB first before we actually query our
maybe
web
you
API
can
here.
comment it at the top. So let's put a comment at the very top. This is arrange.
Right. Yeah. This is arrange.
And then we have an act, which is really just a one line, which is get async.
Yeah. This is the
and
act.
Then we have assert.
We'll have and this is just let's call
everything
this
below is an assert.
Yeah. Utils
Oh, by the way,
something.
small typo, which is discounts details.
What? Where?
Discounts details. var discounts details. The last line.
There are okay here.
Yeah, I think we could call it actually assert because in that scenario we'll actually already invoke the get async and we'll just try to deserialize an object and so on. So I think we could already call it an assertion in that case.
Where's the typo? I don't see a typo here.
Discounts. This would be discount.
Oh, sorry. Okay.
Yeah.
Okay.
I think we could call it assert, so the people are not confused. All right, and maybe before we go further, let's try to do one thing. Maybe let's just do something like discount details should not be null, just to make sure that actually the object is there, and we could even put a breakpoint here maybe to see that the data is there. Yeah, and let's put a breakpoint at the last line of code and debug this test and see what happens.
Okay. Yeah. Okay. Debug the test and yep. So one more thing. Yeah, this actually will run in the background. If you will see, I am already connected to the MongoDB itself. So as you see, we don't have any database right now, but in a minute we should have the test database fully created and ready to. We have some logs.
So as you can see, we have the logs on our app. Let's see. Do we have a data or there was some error? Let's see what happened.
We have you see we have the discount service created, and if you'll see we have the customer, and we can we can view the document, and this is the customer and some random GUID, and the same applies to the discount. So if you'll see, we'll have the discount and the data we actually specified in the test. So this the fixture created this database.
And let's get back to the test. Why there was an error? You forgot to provide the valid ID of the discount. So there's still random GUID.
Oh yeah.
In the endpoint.
So this test will fail.
Yeah.
We'll see.
Just fix the ID and rerun it, and it should succeed.
But one more thing, if we'll refresh the data, you'll see that the database is gone. So this is why we actually implemented this iDisposable pattern, to make sure that actually once we run the whole test, we'll clean up the mess.
Yeah, and again, the iDisposable is the xUnit. This is what the xUnit works, because in any unit you could do something like add an attribute and mark your method with a teardown attribute.
Just make sure that we stick to the xUnit. So the discount ID, we'll use the interpolated string in this case to make sure that we'll get the one, and maybe I'll run you want to debug or run right now?
Yeah, just run.
Yeah, just run. We'll see. So for now, we just want to make sure that this will be not null. And as you saw, there was already in the database, so we can assume it's all green now. So this works.
Cool.
So this assertion actually works.
Yeah, and we could extend this test. Basically, what we can do with this is that now, for example, we could check all of the properties or maybe some properties of the objects, so that we are certain that our DTO returned by the service API, the endpoint, has the same values as the original domain object. We could do these assertions that the customer and maybe the discount should not be null, and then we could check each property one by one.
Yeah.
So maybe we can check
Yeah, so
ID should be customer ID. So you can see we're basically verifying that our DTO properties and actually the values of properties are the same as the domain model properties values.
yeah, just let me type this very quickly to make sure that this
Yeah, so
actually.
here we have 4 properties to verify: ID, customer ID, code, and percentage.
Yeah, this will be faster right now. So
You can just
I'll
do
use that's the customer ID, and this is the customer.id. Then we have the code, and this is the.
Actually, I think you should compare it even to the discount.customer ID. I mean, it's the same, but it's the same, but
Oh, sorry.
just yeah, I think you should. Yeah, it'll be the same in that case, but you can imagine that maybe you using it in some different format. So
Yeah.
okay, I think
so.
that's
In this
all.
case, we want to. Yeah, I think that Okay, I think that specify all.
Let's just rerun the test and let's
Yeah,
call it a day.
we have the same thing. Hopefully this will work. If not, I'll be disappointed. Yeah, practice a lot on my keyboard just to make sure that I will not do as much typos as in a previous episode, because that's kind of shame. Yeah, so this works.
Cool, that's cool.
Yeah.
Yeah, and this is how you can actually test your API endpoints in a way that you verify what the API returns to you as a part of the response, the body of the response. So I think that's you can really write more than that. Within the response object, we could, for example, also verify the status code, the headers, and a few other things. But besides, that's usually all you really care about. The data,
Yeah, actually,
the headers.
Yeah, this actually once you actually get the response, you have plenty of different variables here, and you can test plenty of different scenarios. We simply stick to the one that actually are easy to explain. So and our API itself is not that complicated to actually see whether we have some weird strategies applied properly. Yeah.
Okay,
so that was the easiest part, the easier part, I would say. That was the rating from the app, right?
Exactly. And now let's get into the more interesting part, which is so now imagine that we have our handler, for example, the create discount handler, which is responsible for dealing with the particular use case, which in this case is creating a discount. So it will use our domain, repositories, maybe some domain services, factories, and so on, in order to resolve our use case, which is creating a discount. And now imagine that we want to test it, but not in a way as you would write a unit test, by providing some mocks, tabs, and just verifying that, for example, your repository was called, that your user was fetched from database, and so on. We actually want to put a message into the queue. So somehow we need to send a message to the queue, then grab it from the queue, which in the case is our RabbitMQ service, and then we want our handler to consume this message and handle it and produce some result. So a lot of things that have to be handled, a lot of things that can go wrong, but this is really sort of integration test that gives you quite a good insights and provides some real value. So in that case, we'll need to use all of the fixtures, I think, which is the Mongo Rabbit, which will be the new one, and our web app fixture.
You're correct. So I'll start with the MongoDB fixture. Then we have iClass fixture, RabbitMQ.
Yeah, and we'll also use this web app fixture, which we already did in the previous test. And the only reason we are doing it is because we actually want to start our API in memory. so that the API will be able to consume the message.
Yep.
And actually, we found out that there are some issues with that. Sometimes I'm not sure if this is related to the framework, the library version, or we did something wrong.
Or
But
maybe we are dumb.
sometimes
Yeah.
maybe it could be. Yeah, but sometimes the tests they are being executed just fine and they pass, and sometimes this factory doesn't really start the API and the message is like trying to be processed and it never gets processed, so it's at some sort of log. Hard to tell what's the reason. But as you can see here, we are basically creating the client in order to, just
To make it work.
bootstrap
Actually.
our API. Yeah, just to make it work, just to boost our web API in memory.
Yeah. So that's kind of weird thing, and it's probably something wrong with maybe our code. I'm not sure.
Could be.
But yeah, if you'll spot the issue, just let us know on the Git or on the forum. Maybe we'll fix this. Or the best way would be simply if you could create a pull request for this after you actually see this episode. So we'll test the create discount command, and we'll get to the command handler to just remind what this actually looks like. And so we'll see whether.
Or
So what
maybe,
Yeah.
we're wondering whether we should call it Mongo entity or we should just call it create discount command should create, discount, or should create
Discount,
domain
yeah.
model or whatever. Discount, not discounts.
Or maybe persists discount to Mongo, or I don't know. Because the reason purpose of this is to check whether this actually is stored in the Mongo, not whether we actually instantiate this as a.
Oh, I see. So
as
maybe
a
let's say create discount command should persist discount. Maybe this makes sense. Persist or create, and discount, not discounts, because the single discount. Okay. So
Right.
yeah, that's correct.
Okay, and just mark this as a fact here.
Yeah, and again we'll need the customer first to create a discount. So the same thing as we did before.
Okay. So the customer.
You're missing a no.
Oh, the typo starts now. Yeah, that's a
Yeah.
good thing.
Late hour.
So, yeah, so the customer.test.com. Okay. And we'd like to persist this using our fixture. So the insert async would like to persist into customers collection, and the one we actually want to persist is the customer entity right here. So this is once again this is the arrange, but this is not the end, right? We also want to create this command that actually create the discount.
Yeah. So now we need to create a command because we want to, in the end, we want to invoke the command handler for the create discount. So let's create a new command, and here we need to pass the first one will be the discount ID, which can be an arbitrary GUID value.
Yeah.
Then
we have the customer.
Then we need the customer ID and the discount code and the percentage, which can be anything.
And the percentage. All right. So we have this. So we have the command. Now we'd like to publish this as we do this in the API gateway somehow, right? And for this reason, we will use the RabbitMQ fixture, as you probably expect, right?
Because we don't want to start the API gateway for this test, that's for sure, and we also don't want to, use the post endpoint because it's not really for the designed. It's not really to be used. So we want to somehow put the message into the RabbitMQ send it to the exchange and then put it into the queue. So we have to use our fixture.
So I'll simply type this for now, but this is we'll miss one step between, but this is a fine thing. And one more thing, just to make it clear, the RabbitMQ itself, this whole fixture, if you'll go to the details, you'll see that in the constructor we actually instantiate the whole client for the Rabbit, and we just configure it in a very similar way that you can find in a common package. And this means that because we have some custom naming convention, this is actually the issue I forced yesterday. You also need to make sure that all your configuration will be the same both for your application here and for your integration test here, because otherwise you will get this issue that you can actually publish message, but it is not consumed by any application, simply because you have some mismatch in a convention. So you need to be sure that the conventions and the whole configuration both for your application and test environment is the same. And yeah, so for now, as if you'll see, the publish async simply puts the message on on the exchange. We have this publish async, and we use the same. We don't use the correlation context. We just pass this as an empty, but we use the routing key, which is not the default one, but the custom is made from the name and from the name of the contract and the namespace itself. So just make sure that you will have this one by one copied into your test.
As long as you're using a Rabbit. And we're not sure how it works with all the other libraries. So
all right.
Okay,
so at this point we have the command that actually says that we would like to create a discount, and we publish this. But the question is, how we'll actually know when to check whether we can get something from the MongoDB, right? Because this is done fully asynchronous. So we're not sure whether this will be consumed by our discount service in a second or in a minute or in an hour. We would like to just wait until it's done, and just check then into the MongoDB whether the entity persisted and is the same.
And so before we publish the command, we actually need to get some sort of subscription from our Rabbit fixture, right? So that we will be notified when it actually completed, when the create discount handler completed, and when the event was published to the bus, which in that case will be discount created event. So as you can see, we have this method that subscribes to this particular type of message, and it basically returns the task.
Yeah, actually, this is the task completion source, but they will get to this. I think that this should be called the TSC or something.
Yeah, TCS could be.
Yeah, okay, let's just call this TCS because that will be faster. So we'll also need here
TCS,
ID.
Sorry.
Yeah, okay, and we'll get to this point in just a second. Yeah, so as Piotr said, we have the subscribe and get everything. That's something that was not provided by the common package itself, because we had just a subscribe to event or subscribe command or subscribe event, something like this. So this is something different, and the reason for this is basically, as I said, we want to make sure that once we get this discount created, we would like to look up for the entity. And if you'll see, we pass this function, which is the function from the fixture that actually says that we would, once we actually subscribe and get this message, so this event, discounts created, we would like to get the entity from the Mongo using the ID given in the comment. So this simple as that. So if you'll go to the details, you will see that we use this task completion source actually to make sure that we will await until this message will be received by our test environment. So actually, once we get the event that the discount was created, we'll start looking for this entity in the MongoDB.
Yeah, and one thing, I think we could even make it more generic, because right now, as I can see that we have this discount, which is strongly typed, but it could be like task completion source of T model, right? Which could be generic.
Yeah, in this case, that was simply because we're inside the discount. But of course, you could make it more general and more generic, and you could also share this DB fixture and RabbitMQ fixture across all your maybe put this into common in some testing or something. Yeah, but that was just for this for this purpose. Yeah.
Okay.
Just to make sure, just keep in mind that not everything that you see here is production ready, right? And you should also think for yourself in some scenarios. And this is one of these cases when we definitely could improve this code a little bit. So yeah. Once again, we have this subscribe and get. Once we get this message, we'd like to look for the inside the Mongo entity using this ID. So at this point, we publish the command, and we would like to await, right?
Mm-hmm.
So, and this I could call this created discount or something. Oh, that was bad.
Yeah.
Discount. Yeah, created discount. Let's call this. And we would like to do the creation, task completion source, and task. So at this point, we would await until this will be actually done. So if our discount created event will be published like 1 hour later, we actually started this test, we would await this for the 1 hour, and then we'll let the code
Makes sense.
run. Yeah. So at this point, created discount. If you go, we have the discount entity. So there's nothing more but doing the whole assertions, right?
Yeah, the same as we did in the previous test.
Yeah.
So we can just check the default properties.
Yeah. Should be like command ID. Yeah, simply try to do this customer ID, code, and percentage, right?
Makes sense. And
yeah,
well, I think that's all for the test, right? We have the Mongo up and running and Rabbit.
Yeah, for now, so this is the local host, so this should be working, I think.
Let's try.
Yeah, let's give it a try. We'll see.
It may hang up, but hopefully it will.
I'll just debug to.
Okay.
To make sure, yeah. So right now we should have no database, and this should be created in a minute because we're using this whole MongoDB fixture. And we should have both customer and the discount persisted. Yeah, we have a lot of logs. It's kind of weird.
Cool.
Yep. So we have something.
There's the command, and cool, work.
Yeah. Yeah, and we can just prove this by doing. Yeah, you'll see that we have this discount actually. Yep.
Yeah. So what happened?
Database.
Basically, we sent the request to the message bus. As you can imagine, it was sent by the end user and went through the API gateway. And we tested the whole handler, which is pretty cool.
Yeah. That's basically what the API gateway is doing. They're creating the command and publishing, and we just did the same thing, exact same thing. Maybe kind of bit of simplified because we're not caring about this whole tracing stuff and the correlation context. But this is not the case of, and the purpose of this, that was not the case of this test. So we simply did the same thing, and it worked.
Great.
Yeah.
So maybe the last one thing, which is all about these compose files, because as you can see right now, we are able to execute our tests using SDK, but we could also run them through the Docker as part of our build pipeline, actually.
That's correct. Yeah. So just maybe we could start with the actually inspecting this, and later we'll just see. Okay, so we'll start with the infrastructure. So infrastructure is basically what, the copy paste, right, of what you can see in a DShop.
Just without exposing the
repository.
ports. So because everything will be run internally within the same Docker network, so we are not exposing ports here. And that's it.
Yeah, and there's the network name is different. So that's the only thing. So this is the infrastructure, and we have the integration tests that simply connects to the existing network and runs this Docker file integration and uses the context of the whole directory. So if we'll go to the Docker file integration, it's simply what it does. It copies both discounts and the integration tests to the work directory and run .NET tests. So it uses the .NET CLI to simply perform all testing using the xUnit. And
so
no build, no restore.
So in the multi-stage Docker file, you could basically add this step maybe after the first one, and you could run your unit integration test while actually creating your Docker image. So you wouldn't even have to use the Travis or some other Azure DevOps, whatever you use, and you could just do it on your local machine using Docker.
Yeah.
Okay. Do we need to stop the currently running Docker services containers?
I'll just stop them to make it more clear. So
because if we're using the same container names, it will break. Okay.
So no containers running right now, and we're here in the integration test. So we can now Docker compose, and we'll use the.
I'm wondering whether it will work. I think it's under compose file. So minus.
Yeah.
You have to start it from this directory.
No. Why? No. I could, but it's simply I know, I'm used to run from the exact directory. I know, this is stupid. Okay, so we have this and the infrastructure, and I'll just run this in the detached mode here. Docker compose, sorry, my bad. Compose, okay. So we should have at this point the infrastructure running, okay. And before we actually run the test, we should change something in the code, right? Because for now, if you'll see, we'll reach the same issue that we reached a few times. If you'll see that both RabbitMQ and the Mongo uses the local host, and as you probably know, once we actually switch to the Docker environment, we'd like to use the DNS of the particular containers instead. So if we go to the compose, you'll see that this is the Mongo test and the RabbitMQ tests, and these are the names that we'll actually use instead, right?
Correct. So we just have to use DNSs, and we have to change the code. But I mean, you could also get this from the app settings. It wouldn't be difficult to actually read the app settings and assign those values. But for now, we are hard coding it so that you can see that it works.
Yeah, so the Mongo test, and the same applies to app settings here, right? Because the app itself also needs to connect.
Oh yeah, correct.
To the RabbitMQ.
So the app settings are really for the web API, and the other ones are for fixtures. But you could unify this by loading the app settings into the fixtures as well.
Yeah, this is simply this is the very very simple thing right now. So I think that this is good for now. So
Yeah, let's give it a try.
we can actually Docker compose this infrastructure. Yeah, so this is this, and we'll just build this just to make sure that this actually contains all the changes right now. This will build a Docker image, and it will take a while because it needs to restore the whole references, all the packages from the NuGet. But
It
this
won't be
should
that
not
long.
take much time, I think. Right. It's now restoring. Okay, the reintegration test also needs to be restored. Yeah, okay. So, the moment of truth, right? So, we want to app this with no detached to see the output. And hopefully we did not screw this. I'm not sure. We'll see. Oh, we have something. Failed?
Yeah, I think some DNS is invalid or something. Yeah, it's trying to connect to the local host somehow. Also for the Rabbit and I think for the Mongo as well. So just some.
Yeah, actually,
it uses
this
localhost.
What the hell? To me, this makes no sense. Why this actually would try to
Let's see.
Here we have the RabbitMQ test. We have the Mongo test here. So this is cool. Oh, we didn't change this here, I think.
Could be.
Yeah.
Yeah, you really need to use. I think we could basically switch to the environment named like test and maybe have upsettings test.json or upsettings Docker test.json.
Yeah, we didn't use this. Yeah, but
yeah, we didn't use this.
You get the idea.
It's a good excuse.
That was yeah, I didn't expect this. So RabbitMQ test. Is this? Do I have a typo? No. That's good.
Seems okay. Let's do one more
Yeah,
build.
Yeah, I'll just rebuild this. Make sure. Oh, that's a bummer. Yeah. But as Piotr said, we could put some environment variable that would actually, yeah, would change the app settings. As we actually used to do in the previous episode, because as you probably remember, in the meantime, we could show this, that I need to switch here. If you remember, we had in a Docker file, we had this already set up. So we said that, yeah, we had this environment, and based on this, we looked for the different app settings. So in this case, that will be for the Docker. So yeah, in this case, we forgot to do this. So that's why we had to change this manually to this DNS. But you get the idea. You can put this together on your own. Yeah, let's try this one more time. Hopefully this time this will work, because otherwise that'll be awkward. Oh,
yeah, we have logs.
Yeah, but one failed actually. And
yeah, let's see which one.
Why. So four tests passed, right?
Yeah, one failed. I think it was some endpoint.
And do we have the output from the xUnit? That would be the aggregate exception.
Okay. Blah, blah, yeah, this is all right. So I know the issue. Because it will try to register. It will try to register the Mongo conventions once again. As you can see, we have this error already registered serializer for type decimal. Yeah. So it's really, yeah, I mean, we also face this issue with, for example, Jagger and the metrics library, where I had to use some statics just to prevent multiple registrations. In that case, from, for example, multiple threads running the test in parallel, if that's the case. So if you wanted to make
this is non-deterministic for now, right?
Sorry?
There is a chance that this will actually succeed this time?
Not likely. I mean, we'll have to change in the code.
Oh, no.
For the MongoDB fixture, would have to change, add here some sort of if, I think.
In the fixture.
So in a fixture we have this initialize Mongo, and you run this Mongo initializer here. I mean, there is this static property, but maybe it just didn't work somehow. But this is really not related to test at all. It's more like related to the library, for example, that contains Mongo driver, in which we're trying to register some Mongo conventions and add serializer and so on. And it just fails if we're doing it more than once. And this is because we run multiple, tasks at once. So I'm not sure if the simple static will do here, because there's already such property in initializer itself.
Oh yeah, okay.
Yeah, but this is really like it's nothing to do with tests. It's basically
there's also I think
fixed.
that there's also one more thing, and this is crucial. Definitely worth to mention. The class fixture itself provides the fixture each tests the class that actually tests. So the controllers test or the discounts command test class will get their own instances of the MongoDB fixture, and that is by design. So in case that you would like to connect to the database or to RabbitMQ, you would like to actually keep the single instance of this. So share the same instance across different testing classes.
Mm-hmm.
And I think that this also why we face this issue, because we simply use the class fixture. And in the xUnit, there's also this convention of doing the collections that actually share the same fixtures across different tests classes. But we didn't use this here because we have just for like free tests.
But for example, for RabbitMQ, that could be quite a big difference. If you have a lot of tests using RabbitMQ and you wouldn't use the single instance, single connection, it could take much more time instead. But yeah, this is really like a thing that should be either resolved by using this convention that allows to register this as singletons, or by just fixing our common code for the MongoDB, so we never register multiple conventions or serializers.
I think that if we'll see, shared context between tests. Yeah, and this is the thing that actually allows you, if you'll see, you have the fixture, and you have this collection definition that this is simply a definition that has no implementation itself, and you can then add the attribute that actually allows you to share the same collection across multiple tests classes, and that's the way to go. But we didn't use this because that's kind of ugly, and we have like free tests, and you see now the results. So we have this one test that actually failed. But the good news is actually that the 4 passed. So
yeah, and the whole idea behind testing with when using Docker works. So that's pretty cool.
Yeah, you get the idea. And
we can try one thing just to see if it helps or not. Can you open the MongoDB initializer? But I mean, okay, but since we are using Docker, it won't work because we will have to publish it to NuGet anyway. But if you open this MongoDB initializer class, here is this dummy if initialize return. So maybe if you change the register conventions with initialize equals true, just to make this initialize equals true to be before register conventions, it could be the issue because you have like multiple parallel threads trying to execute register conventions there, and they try to add this. As you can see, we have these serializers added here below. So if these threads try to add the serializers at once, this is why the issue happened. So it's really more about adding here some either doing it like way like
more
this,
checks, or doing this in a log or something.
Yeah, I mean we could use interlogged exchange with a log-free approach to handle this case. But this is the case. It's really nothing to do with tests or Docker. Everything is fine. It's just more about the library itself,
I
which
think
doesn't
can
allow you
get,
to
one shot.
do such things.
Whoa, that did not. Okay, that will not work anyway because
We're using
in
NuGet package here.
Docker
so
environment we use the Nugget packages,
Yeah.
so this will use this will not make any difference here.
yeah,
As you
but
see that this is already built image.
yeah, but we'll see whether it works, or we'll try to
Yeah.
fix this code with some better approach than dummy static block here. But anyways, the test works just fine. It was just a matter of some invalid code here.
Yeah, and and we'll definitely at some point we'll refactor the code, the whole common package, and probably we'll split this to the multiple smaller packages to make it more clear for you, and maybe more, I would say, the users friendly.
Yeah.
And probably extract this to another repositories or organization. We'll see. So at this point, you get the idea. Hopefully, you get the idea of the integration test, and this hopefully this will help you some sort of way.
And this is the first part of the testing. We'll also talk about another approach in the next episode, because as you can see, this is quite difficult and a lot of things can go wrong. If you have multiple infrastructural services, it might be even more difficult or maybe sometimes impossible to create all of these fixtures. And then again, if you like to test some scenarios like I'm sending the message to API gateway, some HTTP request, then it sends the message to the publishes, sends the command to the message bus, then some service consumes this message, publishes the event, another one gets the event, publishes another event, so on and so on. So it's really kind of impossible to create these scenarios incorporating multiple services, which is more like end-to-end testing. And you deal with this, and you test these things using different approach. Instead of doing things like Netflix and testing in production or Facebook, we're using some chaos monkey approach, which to do so, which you need to have really, you have to really be confident with your code and system.
There are some balls required for doing this.
We'll do another episode of testing, and with using some different but pretty popular approach.
Yeah.
Okay.
So stop asking us whether we'll add some tests to our code.
Yeah, we just did.
It works. At least on my machine, it works.
Yeah.
So this is how it is, and unit tests you need to figure it out on your own.
Yeah.
And actually, this is the simplest phase. So
that's
why we skip this.
Yeah. Okay. Cool.
So this is it.
That's all.
Thanks,
for today,
and we'll see you next time.
Okay. See ya.